The future of autonomous air traffic management, ATM, represents a transformative shift in how global airspace is organized, monitored, and controlled. As air travel continues to grow and new entrants such as drones and urban air mobility vehicles emerge, traditional air traffic control systems face increasing pressure. Autonomous ATM offers a forward-looking solution by integrating advanced technologies such as artificial intelligence, machine learning, and real-time data analytics to enhance efficiency, safety, and capacity. At the core of autonomous ATM is the concept of reducing human workload while improving decision-making accuracy. Today's air traffic controllers play a critical role in ensuring safe separation between aircraft, but they operate in a highly demanding environment. Autonomous systems can assist, or in some cases partially replace, human decision-making by predicting traffic conflicts, optimizing flight paths, and managing congestion dynamically. This leads to more efficient routing, reduced delays, and lower fuel consumption. A key advantage of autonomous ATM is its ability to process vast amounts of data in real time. Using satellite-based navigation systems and networked communication platforms, autonomous systems can maintain continuous surveillance of aircraft across global airspace. This enables more precise tracking compared to traditional radar systems and allows aircraft to operate closer together safely, increasing airspace capacity. Such advancements are particularly important in busy regions and for integrating unmanned aerial systems, UAS, which require flexible and scalable traffic management solutions. However, the transition to autonomous ATM is not without challenges. One major concern is ensuring the reliability and safety of automated systems. Aviation is a safety-critical industry, and any technological failure could have serious consequences. Therefore, rigorous testing, certification, and redundancy systems are essential before widespread implementation. Cybersecurity is another critical issue, as increased reliance on digital systems makes ATM more vulnerable to cyber threats. Additionally, there are regulatory and human factors to consider. Governments and international organizations must develop new frameworks to govern autonomous operations, ensuring global standardization and interoperability. At the same time, the role of human controllers will evolve rather than disappear. They will likely oversee automated systems, intervene in complex situations, and ensure ethical and strategic decision-making. In conclusion, the future of autonomous air traffic management holds great promise for improving the efficiency, safety, and sustainability of aviation. By leveraging cutting-edge technologies, the industry can address growing demand and complexity in global airspace. However, successful implementation will depend on overcoming technical, regulatory, and security challenges while maintaining a balanced collaboration between humans and machines.